Hello there, and welcome back. What we're going to do in this video is find an antiderivative of tangent of x. As you see here, we have the integral of tangent of x dx. So the first thing we'll do, since it's not quite clear what the antiderivative of tangent is, we're going to rewrite tangent as sine x over cosine x. And while it might be becoming a little bit more clear, we're still going to do one more rewrite. I'm going to rewrite this as 1 over cosine x times sine x dx. And now if you look at the function the way it's written now, the cosine x is actually part of a bigger function. We have 1 over something. So here it makes sense to do a u substitution with cosine, but before doing so, we need to make sure that its derivative is inside the integral in some form as well. And remember that the derivative of cosine is negative sine, so we essentially have the sine of x, but just we're going to have to adjust for a negative. So u substitution seems to be a good strategy to use here. So we're going to let u equal cosine of x, because then we get 1 over u. And then du is negative sine of x dx, the differential form. And since we don't have a negative inside of the integral sign, we're going to get sine of x dx by itself by multiplying both sides by negative 1. So you have negative du equals sine of x dx. And now to make our substitution, we have the integral of 1 over u times negative du. And since that negative is really a constant, we're going to write it on the outside of the integral sign. It's really a negative 1 getting multiplied. And now remember that the antiderivative of 1 over u is the natural log of the absolute value of u plus a constant. And now we back substitute. U is equal to cosine of x, so we have the natural log of the absolute value of cosine of x plus c, negative natural log of absolute value of cosine of x plus c. Sorry, I misspoke there. And now that is a perfectly fine form for the antiderivative, but we can take it one step further. Remember that the negative out front of the natural log is really a negative 1 multiplied. So by property of logarithms, we can write the natural log of the absolute value of cosine x to the negative 1 plus c. And remember, negative 1 means reciprocal. And remember that the reciprocal of cosine is secant. So we can also write this as the natural log of secant x plus c. So that means we have 2 forms for the antiderivative. I'm just going to write the other one here right next to it. Either one of these is an acceptable form for the antiderivative of tangent of x. So there we have it. Natural log of absolute value of secant x. That one appeases the crowd that doesn't like negatives in expressions. And we have the negative natural log of absolute value of cosine x plus c. That one appeases the crowd that likes to write trig functions in terms of sines and cosines. So there's something for everyone here.